Hello team, today we are going to have a very important lesson. In the lesson we are going to learn basics of structured query language. I am going to explain you what it is and why it is important to know it to work with databases. We'll start from the very basics. We'll learn what SQL is in general, and after that we'll focus on data definition language in SQL. Don't worry, we'll not have only one lesson about SQL. Still, there will be other lessons to learn, but today we are going to build basement for our further learning. In the lesson, we are going to learn what SQL is. I will explain what SQL Sublanguages are. This will give you insights on what we are going to learn in this course. After holding an overview of SQL language, we'll jump to learning of the first SQL sublanguage. We'll learn data definition language in this video. We'll review different statements with create, alter, rename, truncate, and drop statements. Also, on real examples, you're going to see how we can create these statements and execute them against our database. Enough talks. Let's start our lesson. And to start our lesson, let's understand what SQL is and what we are going to learn in this course. SQL stands for Structured Query Language. It is the main specific language used to manage data held in a relational database management system. SQL was one of the first commercial languages to use Edgar Coates' relational model. The model was described in his influential 1970 paper, A Relational Model of Data for Large Shared Data Banks. Despite not entirely adhering to the relational model as described by Coates, it became most widely used database language. SQL became a standard of an American National Standards Institute in 1986 and of the International Organization for Standardization in 1987. And because standardization of SQL wasn't done since its creation, different relational database management systems invented their own differences. Despite the existence of standards, most SQL code requires at least some minor changes before being ported to different database systems. So, SQL itself is a set of operators that allow us to interact with database management system, query data in it, and perform other operations. These different statements and operators informally can be grouped and classified as different sublanguages. They are data definition language. It is a syntax for creating and modifying database objects such as tables, indexes, etc. DDL statements are similar to a computer programming language for defining data structures, especially database schemas. Common examples of DDL statements include create, alter, and drop. Data manipulation language. This is a set of statements that are used for adding, deleting, updating data in a database. Common examples of DML statements include select, insert, update, delete. Data control language. It is a syntax that is used to control access to data stored in a database. Examples of DCL include grant and revoke statements. And the last but not the least sublanguage is transaction control language. This language groups statements to manage transactions in databases. Among examples of TCL, it is worth to mention commit, rollback, and save point. Based on this, we can make a conclusion that the scope of SQL includes data query, data manipulation, data definition, data access control, transaction management, and managing database objects. In our course on real examples, we are going to learn how to work with different groups of statements. Okay, I believe that now you understand what SQL is and what we are going to learn. And as we announced in the agenda of this meeting, let's start learning DDL now. And we will start from the first statement. It is create statement. The general structure of statement is the following. You write create first. After that, you specify what you want to create, whether it is a database, schema, table, view, index. After that, you put name of the database object that you want to create, and optionally, you can put different options. Let's review a few queries with you. To create database, we need to use the following construct. we start from create keyword. After that, we indicate that we want to create database. And by the way, in MySQL you can use both options, either create schema or create database. They are similar. After that, we need to specify name of the database. Usually in SQL, we use single quotes for all string values. That's why I put name of our DB in quotes. Basically, this is enough to create a database. But additionally, we can add more things in this statement. We can add a condition to make sure that we wouldn't even try to create table if it exists already. For this, optionally we can add if not exist. And there are different create options that can be specified separately. For example, you know that sometimes we also want to specify char set and collation. You can write default character set followed by char set that you want to use. And after that you can write collate and specify collation that will be used for this char set. Now this is complete query to be executed against database. Let me start sharing my screen to execute this query together with you. I'm going to show you how you can execute SQL queries from MySQL Workbench. If you don't have MySQL Server installed and also you don't have MySQL Workbench on your computer, please refer to the previous lessons where we together installed all required applications for MySQL Relational Database Management System. You can execute any SQL query you wish directly from SQL Editor. Just click on this icon that is called Create New SQL tab for executing queries. A new tab will be opened. Now you can type any query you wish here. To save time during this video lesson, I already pasted here the query we reviewed to create a database. Press a pause for a few seconds if you need to type the query in your SQL editor. One more important thing to mention here is that SQL is not case sensitive. That means that no matter how you would spell create, it would still mean the same. You can write it with capital letters or lowercase. Technically speaking, it doesn't matter at all. But still, there is a common practice to write all SQL keywords with capital letters. If you are ready, let's execute the query. To execute all commands in this SQL file, you have to click this lightning icon. If you want to execute only selected commands, we have to select first SQL instruction and after that, click on lightning icon. And if you want to execute only one statement under keyboard cursor, you have to click this icon. I executed query. After it has been successfully executed, I click refresh icon. And I see that new database is created. Let me select this database to make sure that all other queries will be executed against this database. I am going to save each query that we will review today with you in a separate file. In attachments to the lesson, you will be able to find all these queries. Now, let's learn how we can create table. I believe you already understood the general structure of create query. But still, on the slide you can see specifics of create table statement. This query is much more complicated than create database query. We can come up with some different combinations and variations that it will take more than one slide to describe all of them. That's why I would try to share with you the most general and high-level structure of this statement, mentioning the most important things in my opinion. In case you would like to know more details, you can always refer to the official documentation. Basically, we need to write create table, followed by table name. And after that, in parentheses, we have to list all columns with their data types, specifying size for each field if needed. We can specify primary key column name. And if we need, we can create index by specifying its type, column name, sorting, that might be either ascending or descending, and its visibility, just to remind you that it might be visible or not visible. In case you're not familiar with indexes in databases, please Make sure you watched previous lesson in this course about indexes in databases. We reviewed all properties of indexes in details there. On the example, you can see that after we listed all columns and added necessary properties to columns, we can specify engine type that we want to use for this table. I believe you remember that we can specify char set and collation on different levels. To specify char set and collation on the table level, you can put these statements at the end of the query. That's it. Let's execute real query against database. Here in example, you can see SQL create statement that will create a separate table for us with name test table in test database. Pay attention that we separate database name and table name with dot. In case you selected this database in MySQL Workbench, there is no need to specify the full table name to make sure it will be created in the current database. In this case, this declaration is redundant, and you can remove it. Result will be the same. Here's a list of attributes that I wanna have in my table. Next to ID attribute, I specify all properties related to this column. It is of type int, not null, and auto-incremented. First name attribute is of type varchar with maximum length of 45, with null default value, and so on. Primary key is ID column. I create unique index with name email unique for email column with ascending order. And also, I specify engine, char set, and collation. Is that clear? And even in case you have any questions, you can always ask your questions in comments to the video, and I will be happy to answer. Let's execute this query. And we see that query has been successfully executed. After we refresh, we see that test table is created. You already saw how to create index during the creation of the table, but let's imagine that we create a table and we simply forgot to create an index. We still can create index afterwards. Let's learn how to do this. On this slide, you can see structure of create index statement. During the creation, we need to specify which type of index we would like to create. The difference between these types was covered in the lesson about indexes. You specify index name and on which table and column you would like to create this index. On the slide, you can also notice that there might be different index options, index types, algorithm options, and log options. Let's create index for our new table. Just for the sake of example, let's create an index for the first name column. And here on the screen you can see simplified version of create index. I specify name of my new index, table, column in this table, and index option. Let me execute this query. We see the query has been executed successfully, but it is obvious that no rows were affected. To make sure that we really created index we needed, I open Alta table, and on Index tab I can see the new index with my name that I have just created. That's how easily I can create indexes. Also, index might be added as part of Alta table instruction, but we are going to review this later in our lesson, when we'll start learning of Alta statement in details. One of my main goals as a tutor is not just to teach you each possible combination of query, but also I have to teach you how to understand the documentation in order you could easily proceed your self-education. Together we reviewed few queries already. And for example, if you need to create view via SQL, you don't need to open this lesson. You can always open official documentation of specific relational database management system and check the details there. For example, now on the screen you can see documentation page of MySQL. From this page you can find general construction of create view statement and all possible options. We have just reviewed similar ones, and I believe you already understand how to read this syntax by analogy. Press a pause for a minute if needed, or just feel free to explore attachments to the lesson and find this link to the official documentation that I've shared with you. Additionally, if you scroll down a bit, you can also find examples of SQL queries. You can create your own queries for your database and your application by analogy. And at the meantime, let's proceed with another examples. Let's learn now such important statements as alter statements. We use alter statements when we need to update database object. No matter whether we need to update database or table, we are going to start query with alter keyword. As you already know how to use documentation, I don't see a lot of reasons to go over each alter statement. I mean, I will not demo you now all possible variations of alter statements. That includes adding columns, adding column properties, changing of char set and collation, and lots more. For the sake of the demo, I will demo only one case with altering table, in order you could understand how it works. Let's adjust this table. We are going to add new column after the first name and adjust first name index to change ordering in there from ascending to descending. I write alter table, and after that I specify the full table name. And after that I put instructions related to my table update. I wanna add column with name last name, with varchar data type, and default null value after first name column. To update index, I need to drop existing index first, and after that to add new index with descending order. Drop command removes index. Let me execute this query. Query is successfully executed. Let's open table now. And here is our new column. We can also check our index. We can see that we have descending order in our index. Basically, that's all what I wanted to share with you regarding alter query. You can rename table using separate statement from data definition language that is called rename. We can easily rename our table to test TB. And after refresh, we see the table name has been changed. One more interesting statement, truncate. We can create statements that will empty all table. We need to add some fake data in it first. For example, let me add just one row in this table. Give me a few seconds. As you see, now we have some data in the table. And when I try to extract all rows from table one more time, I see that my row is in place. If you're interested how to perform such basic operations as data insertion inside Workbench, please refer to lesson about MySQL Workbench. Now we can execute the following statement. Truncate test TB. It should remove all rows in table. And you can see that all rows have been removed. Let's move on. And the last but not the least thing for today that I'd like to show you is drop statements. We use drop statement when we need to remove database object. For example, if you want to remove table or database, you have to use drop statement. Let's review example of deletion of our database. To delete database, we have to execute the following query. Drop database and database name. Everything is simple. According to documentation, you can add if exists check to drop database only if it is present. That's all for this lesson. Let's recap what we have learned today. We have learned a lot of different things in this lesson. Some of them are: now you know what SQL is. After this lesson you know SQL Sublanguages. They are DDL, DML, DCL, and TCL. On real examples we learned create statements. Also, I explained alter, rename, truncate, and drop statements. After this lesson you know how to build queries with mentioned statements. That's all for this lesson. Thanks you all for your attention. Have a great day and see you in the next lesson.